Intermediate Algebra for Statistics. Using the square root property to solve quadratic equations, Part 3. Lesson objective: make predictions with a quadratic function in vertex form. Lesson objective: make predictions with a quadratic model in vertex form. Example 9. Average monthly participation in the food stamp program is shown in the table on the next slide for various years. Let f of t be the average monthly participation in millions in the food stamp program in the year that is t years since 1990. Number 1. Find an equation of f. Number 2. Estimate when the average monthly participation in the food stamp program was 30 million. Solution. So here we have the data. This is the year, and this is the average monthly participation measured in millions. Our independent variable is t, the number of years since 1990. So in this case, t is 6, t is 7 here, t is 8, so on and so forth. We first need to put this data into our list 1 and list 2 and perform a scatter plot or a scattergram. So here we have our data graph. This definitely looks like a parabola. The lowest point is when x is 10 and y is 17.2. So we will use this as our vertex. So that means h is 10 in the vertex formula and k is 17.2. Plugging this into our equation, we have f of t equals a times t minus 10 quantity squared plus 17.2. So we have our h and our k. We need to figure out what is a. So if we imagine a parabola going through this vertex that comes close or contains a data point, I'm going to use this data point here, 6, 25.4. We can find the value of a. Our y was 25.4, our x was 6, we plug that in. Now we follow the order of operation here. 6 minus 10 is negative 4. We now need to square. Negative 4 squared is 16. So now we have a linear equation. One variable, a. Subtract 17.2 to both sides. We get 8.2 equals 16a. Divide by 16, and a is approximately 0.51 to 2 decimal places. So we have our function. F of t equals 0.51 times t minus 10 quantity squared plus 17.2. Graphing the model with the data, we see that this parabola models the data pattern well. So for number 2, we want to know what values of t when y is 30. So we substitute 30 in for f of t. Next, we need to subtract 17.2 to both sides. Now we need to divide by 0.51 and then use the square root property, and we have the equation t minus 10 equals plus or minus the square root of 12.8 divided by 0.51. Lastly, add 10 to both sides, and we have t equals 10 plus or minus the square root of 12.8 divided by 0.51. Writing this as two equations, and we need to approximate this because these values here will be our time. So we have t is approximately equal to 10 minus 5.01 or 10 plus 5.01, and you should use your calculator to verify that this is true. So we have t is approximately equal to 4.99 and t is approximately equal to 15.01. This means the model estimates that the average monthly participation in the food stamp program was 30 million people for both the year 1995, and that's 5 years more than 1990, and in the year 2005, and that's 15 years since 1990. Example 10. A study compared the speed x in miles per hour and the average fuel economy y in miles per gallon for a certain type of car. The results are shown in the table below. Number 1. Find a quadratic model in vertex form for the given data. Number 2. Estimate the fuel economy when the speed is 70 miles per hour. So this is our independent variable, speed, and our dependent variable is fuel economy. So our first step is to enter this in list 1 and this in list 2. Solution: use a graphing calculator to draw a scattergram. So I entered the data in list 1. In list 2, I entered the fuel economy. Hitting second and y equals stat plot, and then zoom stat number 9. We see the data. It does look somewhat quadratic. The highest point is 45, 30.2. So when the speed was 45 miles per hour, the fuel economy for this type of car was 30.2 miles per gallon. We're going to let this be our vertex. So that means we now know h is 45 and k is 30.2. So we need to find one more parameter, and that is a. So if we can imagine a parabola going through this vertex, modeling this pattern of data, we will need to use one more point to find the value of a, and I'm going to use this point. X is 20 and y is 25.5. So we have our equation here. X is 20 and y is 25.5. This is an equation with one variable, a, and I can solve it. Following the order of operation, I have to do parentheses first. 20 minus 45 is negative 25. Next, I square. So now I have a linear equation. I want to subtract 30.2 to both sides. Then finally divide by 625. So a is approximately equal to a negative 0.0075, rounded off. So now we have our function. F of x equals negative 0.0075 times x minus 45 quantity squared plus 30.2. To see how well this function models the data, I type in the equation in y1, hit graph, and we see this parabola is modeling the data points well. We have our function here. We need to compute what is f of 70. What is the estimated fuel economy when the speed is 70? Everywhere we see an x, we substitute a 70. So following the order of operations, we do parentheses first, then we square, then we multiply, and finally we add. 70 minus 45 is 25. 25 squared is 625. Multiply our value of a and add that number to 30.2, we get 25.5125, which is approximately 25.5. So in the terms of this problem, we would say the model estimates that the average fuel economy for this type of car is about 25.5 miles per gallon when the speed is 70 miles per hour. Another way we could have computed this value is hitting second and trace, which is calculate. Select number 1, value. It asks x equals, we type in 70, and we see the output for y is about 25.5. Thanks for watching.